Our next visit is the Habito Labyrinth here in the School of Religious Studies at SMU. And this is a beautiful contemplative space, and it's enhanced by the labyrinth design behind me. Now, there's a question between these words you may have heard, labyrinth or maze. Is this a labyrinth or is it a maze? Are they the same or are they different? And the way we usually use the word, a labyrinth refers to a winding path in which there's only ever one choice at any point. Unlike in a maze, where you may have decisions, you may have different paths you can take, and the puzzle is to solve the maze. Can you find, among all the different turns you might make, the one path that leads to the exit of the maze? Here, you have no choices. There's only one path to follow. So what could be interesting, especially from a mathematical point of view, about a labyrinth? There's no puzzle to solve. Or is there? The problem becomes not how to follow the path, but how to construct the labyrinth in the first place. How can you make a path that winds around itself so many times, never repeats, and yet only has one route that takes you from the outermost point right into the center? And how many different labyrinths could there be? Is this the only one, or are there many? Those become the questions that mathematicians are interested in. And I will show you a technique that you can use to create a labyrinth much like this one. Here's how it works. It's very simple. Take a piece of paper. It doesn't have to be graph paper, although it helps a bit. And I want you to draw just a big plus sign, just like that. That creates 4 regions. And each one of those regions, I want you to put an elbow, just like this. All the same in each one of the 4 sections. That's a pretty easy pattern to remember. And then finally, I want you to put a dot in each corner of the diagram. This is called the nucleus of the labyrinth. Now, to convert the nucleus into the full labyrinth that you can actually wander around in, if you built it big, I want you just to connect the bottom 2 closest segments like this. That is going to become the center of your labyrinth, the goal to which your path is inevitably taking you. And now the rule is always connect the 2 points on the edge of the nucleus that are closest together that have not yet been connected. So I'm going to connect here to here, and then I'm going to go back here and connect that around to here. And I'm going to keep going around, always starting at the first unconnected point on the left and ending at the first unconnected point on the right. I'm almost done. I'm going to barely fit this on the paper. Got one more line to go. Well, we'll just have to remember there's a passage here at the bottom of the paper. So, moral of the story is, start your nucleus a little higher on the paper than I did. Okay, and now this becomes a labyrinth, which we'll now try to trace. We'll follow the end of the pen. And again, there's only one way to go. I've got to stay between the lines. And you see, it's taking me back and forth in a winding, turning path that never retraces. Here's where I have to go in that passage that went off the edge of the paper. But that doesn't matter. I can keep following. It might seem like I'm not getting anywhere because I keep going back and forth in this meandering fashion. But you can see I'm definitely in new territory. And indeed, my one path has taken me to the center of the labyrinth. So as I said, that's an easy way, easy to remember for you to create a labyrinth at home or in your class. And the interesting thing about that is this exact design, this exact pattern, starting with the nucleus and with all of the other passages of the labyrinth scratching around it, was found on the back of a clay tablet from Babylon that was lost in a fire in a palace in 1200 BC. So when you make this labyrinth, you'll be using the same pattern that people have been using for over 3 millennia.